All right, so today we're tackling matrices. This is our last topic as we get ready to get into reviewing for the end of course exam. And matrices is just a way to group things together and do operations. There are certain functions that we can do with, or operations that we can do with matrices, just like we do normal addition and subtraction and so forth. And there's other ones that we can't do. Certain of the properties of the associative and community properties don't apply. So a matrix is basically, it looks like a square that has letters or numbers in certain cell locations. So I'm just going to create this little matrix here and put the letters A, B, C, D in there. And what we have to be able to do for some parts is we have to be able to, describe the dimensions of our matrix. And our dimensions of our matrix is basically our number of rows by the number of columns that you have. And we need to know this because when we get to do some operations today and through the rest of the lessons, certain operations we can't do unless there's a certain arrangement with the rows and the columns when you have multiple matrices. So for right now, we would say this is a 2 by 2 matrix is what we would say that we have right now. It is 2 rows by 2 columns. As I look at the next example, again, it's rows by columns. This is technically a 4 by 1 matrix. Again, it is the number of rows that you had followed by the number of columns. And then the last example down here would be a 1 by 3 matrix because it has 1 row and there's 3 columns in it. So that's one thing you have to be able to look at. Also, because part of it is sometimes some of our combinations of things takes us from being a certain dimensions matrix into another matrix that's out there. Before I get into it too detailed, I want to show you this. This is a screenshot of what Big Ideas has when you click to type to go click in the fill in the blank. It has this little pop-up thing here. And what I really want to draw your attention to is these last 5 little 5 things over there on the right-hand side, because those are all our different matrix stuff. And so what I try to do is I actually sent out another page to you all that, as I scroll over here, I kind of identified what the different buttons do over in those 5 little buttons there. So, like for example, button A, when you press that one and then the fill in the blank, it just puts a 1 by 1 matrix on your screen. And then from there, you can add to it. You can add an extra row or an extra column by pressing D and E, and that just adds an extra column or extra row. Just depends on which one you do. But A, B, and C are basically your basic 1 by 1, 2 by 2, and 3 by 3 matrix, just to give you a template. And so, if you had, for example, something that needed to be, 3 rows by 4 columns. So it had something that looks like this. Then what you would do is you would choose a 3 by 3 matrix and then after you do that, then you would press the D button and that would add an extra column on top of it. So you'd first start off to do the C button and then you would do the D button and then you would eventually get something that looks like that. And then you could start filling in what you have in spots. And again, the E button just puts an extra row below what you already put in there as your beginning template. Because your answers as we go through here today, some of your answers got to be put in that matrix format. So just wanted to show you kind of how you would go about doing that. So as we look at it, we get to do some operations here. We're going to mainly focus on adding, subtracting matrices together today and doing scalar multiples. Another lesson we'll do multiplying matrices. We never have to divide matrices. That is not an operation that works with matrices. So today we focus in on the adding and subtracting and then the scalar multiples. So when adding and subtracting, in order to do it, here's a key little note here. In order to add or subtract, the dimensions in the matrices must match. All right, so they have to have the same dimensions. So as I look at my generic template up here, I have a 2 by 2 matrix being added to another 2 by 2 matrix. So that means I'm allowed to go ahead and combine the two things together. If I don't have the same dimensions, then I can't add or subtract them, and that would just stop. So when I do have the same matrix, same dimensions, what we do is we take the items in corresponding locations, and we get to, in this case, add them together. So, for example, A and E are in the top left corner of their matrix. So that means that in the top left corner of our answer matrix, I can do A plus E. I can take what those two things are and add them together. In the top right-hand corner of my matrix, and each one is a B and an F, so to get the top right-hand corner of my answer matrix, I would just add B and F together. And then we would follow suit with the bottom. Bottom left has C and G in the bottom left. We can just add those two corresponding cells together to get the answer in our cell for the answer. And then the last one, we would get to add D and H together to get the answer that goes in that bottom right-hand corner. Your answer matrix, when you're adding and subtracting, should mirror dimension-wise what your two matrices that you're adding together, or your matrices that were being added together or subtracted. It's only when we multiply matrices together do we actually change the structure of the dimension shape. And again, that's another lesson we'll get into. So the example I have down here is we have a 2 by 2 plus another 2 by 2. And so what we want to be able to do is say, okay, what would my answer look like? Well, we can basically go, okay, top left, I'm going to take 1 plus 0 because that's in the top left of the other one. And then I would say, let's take 3 and add it to 6 because those are both in the top rights. Then 9 plus 3 because they're both in the bottom lefts. And then 7 plus 4. And then to finish up, to clean it up, we'd actually do the addition. So we would say 1 and then 9, 12, and 11. And that would be my answer. And so like for big ideas, you would go in there to the fill in the blank, hit the 2 by 2 matrix, and then go ahead and start typing those numbers in the cells. Now, for labeling purposes, just in case they ask you any problems like this, as you know, I'm going to write a generic matrix here. If this is matrix A, we would say the top left corner would be A1 is what it would be. And then in the top right, we would say it would be A and then 1, 2, meaning row 1, column 2. And then we would have A, 2, 1. And then in the bottom right, we'd have A, 2, 2. And that's how we would kind of label each little piece. Again, we're creeping up on the eclipse here. So I got 3 little practice problems where you actually get to go through and actually find those answers if possible. Like for example, on number 1 here, we can do the math because it's a 2 by 2 plus another 2 by 2. And so that would give me, as we write the answer, -3 plus 4, and then 4 plus 0, 9 plus a -5, and then 6 plus 7. And then we would clean that up and say that is 1, 4, 4, and 13 for the final answer. On the next one, this is it's again number of rows, so 1 by 2, and then it is a 2 by 1. Well, these things don't match. The dimensions don't match. So with that in mind, we cannot add or subtract. Can't add or subtract. So you're done. All right, we cannot combine them. As we do number 3, we get to subtract the 2. Again, as we look at it, it is a 2 by 3, 2 rows by 3 columns, 2 rows by 3 columns. We can now subtract So I'm going to do this, so we'll get 6 minus 5, and then 5 minus 5, and then 3 minus 5 for the top right. Then we go 8 minus 4, 7 minus a minus 6. We show the double negative, 8 minus a minus 3. And then in the final answer, we'll clean it up, say -1, 0, -2, 4, 13, and 11. And that gets us through the combinations there. Again, to just make this a shorter upload, I'm going to go ahead and hit stop, and we'll add another video here in a second.